There's a very simple idea at the heart of quantum mechanics. So simple, in fact, that people refuse to believe it. They insist there must be something behind it, some hidden machinery, some secret picture, some deeper explanation that will make it feel reasonable again. There isn't. The idea is this: nature does not decide what happens until you ask the question. That sounds innocent. It isn't. In everyday life, things have properties whether you look or not. A ball has a position. A clock has a time. The world politely exists in advance, waiting for you to notice it. Quantum mechanics does not work that way. At the smallest scales, the universe keeps its options open. It does not secretly know the answer. It does not carry around a script. It offers possibilities, and only when you force an interaction does one outcome become real. People hear this and say, that can't be right. Reality can't be that lazy. Nature doesn't care what you find reasonable. This single idea, nothing exotic, no equations, yet breaks more intuition than any complicated theory ever could. And once you accept it, everything else in quantum mechanics stops being mysterious and starts being disturbing. The world does not make up its mind in advance. Let me start with a confession. The biggest difficulty with quantum mechanics is not the mathematics. The equations are perfectly well defined. They're strict, disciplined, and they work with embarrassing accuracy. The real difficulty is psychological. Quantum mechanics asks you to give up an assumption so basic that you didn't even know you were making it. The assumption is this: that the world has already decided what it is before you look. The assumption you never question. In ordinary life, this assumption feels obvious. A cup sits on the table whether you look at it or not. A train has a speed whether you measure it or not. A coin is heads or tails before you lift your hand. This belief is so deeply wired into your thinking that you confuse it with reality itself. But it's not reality. It's a B. What classical physics encouraged you to believe. Classical physics didn't just describe the world, it encouraged your intuition. Newton's laws made the universe feel mechanical. If you knew enough, you could predict everything. Every object had a position, a velocity, a future trajectory. The universe was like a perfectly written novel, already complete, just waiting to be read. That idea felt comforting. It made ignorance feel temporary. Quantum mechanics destroys that comfort completely. The simplest quantum statement. Here is the simplest quantum idea, stated as cleanly as possible. Before measurement, physical quantities do not have definite values. Not hidden values, not unknown values. No value. That sentence is short, and it's devastating. Why this sounds like cheating? People hear this and immediately protest, but surely the electron must be somewhere. That protest is intuition screaming. Quantum mechanics answers calmly. No, it does not have a position until position is measured. Not because we're clumsy, not because we lack information, but because position is not a property it carries around. Probability is not ignorance. This is where people usually make a fatal mistake. They think probability means ignorance. They think quantum mechanics is saying, we don't know what the electron is doing, but it is doing something. That would be classical probability. Quantum probability is different. Even with complete knowledge, the theory only gives probabilities. There is nothing hidden underneath, no secret plan, no backstage script. The universe itself does not know the answer in advance. The shock is not the uncertainty. People think the shocking part of quantum mechanics is uncertainty. It's not. The shocking part is that uncertainty is not a flaw. It's fundamental. The world is not fuzzy because we are ignorant. It is fuzzy because that's how it is. The question that breaks you, try asking this question honestly. What is the electron doing right now before I measure it? Every classical instinct demands an answer. Quantum mechanics gives you none. Not because it's incomplete, but because the question has no meaning. The theory does not fail to answer it. It refuses to. The mistake of demanding reality be complete. We assume reality must be complete at every moment, that everything must already be settled, waiting to be revealed. Quantum mechanics says reality is not complete until interaction occurs. That's not mysticism. That's operational fact. Measurement is not passive. This is another place. Intuition collapses. In classical physics, measurement is passive. You check what's already there. In quantum physics, measurement is an event. It does not reveal reality. It creates a specific outcome. Before measurement, there are possibilities. After measurement, there is fact. And the transition is not gradual, it's abrupt. Why this feels like the world is lazy? People say, so the universe just waits until someone looks? That's not quite right, but it's closer than classical thinking ever was. The universe does not store unnecessary information. It does not assign values it does not need. Only when an interaction demands a definite outcome does one appear. The two outcomes illusion. Consider the simplest experiment, measuring whether something goes left or right. You want to believe the answer existed beforehand. Quantum mechanics says there were two possibilities, both real in a statistical sense, and neither actual until the measurement. That's not indecision, that's efficiency. Why this destroys classical realism? Classical realism says objects have properties independent of observation. Quantum mechanics says properties are defined in relation to measurement. That single shift destroys the entire classical picture, not gently, completely. Why this is not philosophy? People try to escape by calling this philosophy. It's not. It's physics backed by experiment. Every attempt to restore pre-existing values predicts results that nature does not produce. Nature has been tested. It refuses to cooperate with intuition, the comforting lie of hidden variables. For decades, people tried to rescue classical thinking. They said, fine, we can't know the values, but they must exist. So they invented hidden variables. Nature rejected them cleanly, repeatedly, without apology. The real meaning of quantum weirdness. Quantum mechanics is not weird because it's complicated. It's weird because it's honest. It refuses to invent stories where none are required. It refuses to pretend that unmeasured things must be definite. Why your brain hates this? Your brain evolved to survive, not to describe reality. It evolved to track solid objects moving slowly in space. Quantum mechanics lives far outside that evolutionary training. Your discomfort is not a warning. It's a symptom. The first hard lesson. Here it is, stated plainly. The world does not contain answers to questions that have not been asked. Measurement is the act of asking. Reality replies. Before that, there is nothing to reply with. Why this isn't nihilism? People worry this makes reality unreal. It doesn't. It makes it conditional. Conditional on interaction. Conditional en contexte. Conditional on the question. That's not weakness. That's structure. The simplest idea, restated. Let me say it one more time, because everything depends on it. Quantum mechanics does not describe what is. It describes what can happen and with what probability. And that is enough to build a universe. Where this is going next. Now that you've swallowed this idea even reluctantly, the next questions become unavoidable. If reality isn't decided in advance, what exactly exists before measurement? Why does one outcome appear instead of another? And why does the world look classical if it's built on this uncertainty? Those questions feel harder. They aren't. They just demand that you stop lying to yourself. The universe keeps its options open. Once you accept that the world does not decide outcomes in advance, a new question immediately attacks your intuition. If nothing has a definite value before measurement, what exists instead? The answer is simple. And it's the part people work hardest to misunderstand. Not one thing, many possibilities. Before measurement, a quantum system is not undecided. It is not confused. It is not hesitating. It is in a superposition. That word scares people because it sounds technical. It isn't. Superposition simply means this. Multiple possibilities exist at the same time and all of them matter. Not as guesses. Not as ignorance. As real contributors to what will happen. Why either or thinking fails? Your brain is addicted to either or. Either the electron is here or there. Either the light went left or right. Either the atom decayed or it didn't. Quantum mechanics says, not yet. Before measurement, the universe refuses to commit to a single answer. And it does this without contradiction. Superposition is not a blur. People imagine superposition as fuzziness, like something smeared out. That's wrong. Superposition is precise. Each possibility has a specific weight, a specific phase, a specific mathematical role. Nothing vague, nothing sloppy. The universe keeps multiple books balanced at once. Why this is not multiple universes? At this point, people panic. They say, so all possibilities are real at the same time? Careful. Quantum mechanics does not say multiple outcomes happen. It says multiple possibilities exist. Only one outcome ever occurs. And the theory tells you the probability of each. No extra storytelling required. The two-slit experiment. Again, let's return to the simplest experiment that refuses to behave. One particle, two slits. Before detection, the particle is not choosing a slit. Both possibilities contribute. That's not metaphor. That's why interference happens. If the particle had secretly chosen one slit, the pattern would disappear. It doesn't. Nature refuses to cooperate with that lie. Possibilities interfere objects. Do not. This is the key difference between classical and quantum thinking. Objects don't interfere. Possibilities do. The future outcome depends on how different possibilities add or cancel. That's why you cannot replace quantum mechanics with classical uncertainty. The math is different. The behavior is different. The universe notices. Why you never see superpositions directly? People ask, if superpositions are real, why don't we see them? Because interaction destroys them. The moment the system interacts strongly with its environment, possibilities stop interfering. They decohere. The system looks classical, not because quantum rules stopped working, but because they became invisible. Decoherence is not collapse. This distinction matters. Decoherence does not choose an outcome. It removes interference. It explains why possibilities stop mixing, not why one result appears. Measurement still does that. And measurement is not gradual. The suddenness people hate. People want collapse to be smooth. They want nature to ease into decisions. It doesn't. One moment, possibilities. Next moment, outcome. No transition you can watch. No halfway state. That abruptness is real and experimentally unavoidable. Why this feels like magic? Because we're used to processes. We want a mechanism. Quantum mechanics gives you rules instead. And the rules work even when you refuse to imagine a mechanism. Stop asking which one was real. This is another trap. Before measurement, asking which possibility was really real makes no sense. They were all real as possibilities. Reality doesn't owe you a single storyline until the interaction demands one. Why this does not mean anything can happen. Quantum mechanics is not permissive. It is extremely strict. Some possibilities have zero probability. They do not occur. Others occur with precise frequencies. Nature is random but disciplined. The universe is efficient. Here's a way to think about it that won't betray you later. The universe does not compute answers it doesn't need. It keeps options open because committing early would be wasteful. Only when interaction forces a choice does nature pay the price of deciding. Why classical reality is an illusion of scale. At large scales, superpositions decohere almost instantly. Possibilities stop interfering before you can notice them. So the world appears classical, not because it is, but because quantum effects cancel out. Classical reality is not fundamental. It's an approximation that works extremely well for big things. The second hard lesson. Here it is. Before measurement, reality is not a single story. It is a structured collection of possibilities. And the structure matters. Ignore it and predictions fail. Why this breaks intuition completely? Your intuition demands one history, one present, one future. Quantum mechanics says, no, there is one outcome, but not one path to it. Why this is still the simplest idea. People think this is complicated. It's not. The complicated part is letting go of assumptions you never knew you had. Once you do, the rules are clean. Uncomfortable but clean. Where this leads next. Now there's only one mystery left. If multiple possibilities exist before measurement, why does only one outcome appear? Why this one and not another? Why probability and not certainty? And why does nature refuse to explain why it chose what it chose? That's where we finish. Why nature never explains itself. Now we arrive at the place everyone secretly hoped we wouldn't. Probability. This is where people finally give up trying to make quantum mechanics feel reasonable and start trying to make it feel acceptable. They shouldn't. Quantum mechanics is not here to comfort you. It's here to tell you the truth. The final question everyone asks, after everything you've accepted so far, that reality isn't decided in advance, that multiple possibilities exist at once, that measurement creates outcome. You ask the final desperate question, why this outcome? Why this one and not the other? Why did the particle go left instead of right? Why did the atom decay now instead of later? Why did this detector click and not that one? Quantum mechanics gives you an answer. You just don't like it. The answer you don't want. The answer is, there is no reason, only probability. That sentence sounds offensive because you were trained to believe that every event must have a cause that explains it completely. Quantum mechanics disagrees. Probability is not a temporary excuse. People keep hoping probability is a placeholder. They say, surely one day we'll find the deeper reason. We looked for a long time, and nature said no. Not, we haven't found it yet. No, probability is not covering up ignorance. It is the final description. What probability really means here? Probability in quantum mechanics does not mean we don't know what will happen. The system knows, but we don't. There's a hidden coin flip somewhere. It means there is nothing to know. The universe does not store a future outcome waiting to be revealed. It generates one randomly, but according to strict statistical rules. Why this is so hard to accept? Because randomness feels like failure. It feels like physics throwing up its hands and saying, I don't know. That's not what's happening. Quantum mechanics says, I know exactly how often each outcome occurs, and that's all there is to know. That's confidence, not weakness. The discipline of randomness. Quantum randomness is not chaos. It's discipline. You can predict averages with incredible accuracy. You can build machines that rely on it. You can bet your life on the statistics. What you cannot do is predict individual events. And that limitation is permanent. Stop demanding a story. People want a story behind every event. This happened because that happened. Quantum mechanics refuses to provide that narrative. It gives you a rule book instead. And the rule book works even when the story is missing. Why? Why is the wrong question. Physics answers questions of the form. What will happen if I do this? How often will I see that outcome? What correlations should I expect? It does not answer questions of the form. Why did this specific event occur? Why now? Why not the other one? Those questions assume the universe owes you intention. It doesn't. Nature is not trying to be deep. People turn this into philosophy. They say, the universe is mysterious. Reality is unknowable. Consciousness must be involved. No. Nature is being economical. It produces only the information required by its own rules. Nothing more. The coin that isn't flipped. Think about a fair coin. Classically, the result is determined by forces, even if you don't know them. Quantum mechanics is not like that. There is no hidden force deciding the outcome. The coin is not flipped in advance. The result appears at the moment it's required. Why? This makes people angry, because it feels like cheating. You want closure. You want explanation. You want inevitability. Quantum mechanics offers none of these. It offers reliability instead. Reliability beats explanation. You can explain something beautifully and still be wrong. Quantum mechanics doesn't care about beauty. It predicts outcomes correctly. Every time. That's the standard science uses. Not émotionnelle satisfaction. The final misunderstanding. People say, so quantum mechanics says reality is random. That's sloppy. Quantum mechanics says events are random, not reality. The structure is rigid. The rules are exact. The statistics are ironclad. Only the individual outcomes are unpredictable. That distinction matters. Why classical thinking keeps sneaking back? Because classical thinking flatters the ego. It tells you the universe is understandable in your terms. Quantum mechanics tells you something more honest. Your terms are local. Your intuition is limited. Reality is under no obligation to match them. The third hard lesson. Here it is, the final one. Nature does not explain itself. It behaves, and physics exists to describe that behavior as accurately as possible, not to satisfy curiosity about ultimate reasons. Why this is still enough. People worry this makes science incomplete. It doesn't. It makes it finished where it should stop. Science tells you what can happen, how often it happens, how outcomes correlate. Asking for more is asking for something science never promised. The illusion of lost meaning. Some people fear this drains meaning from the universe. It doesn't. Meaning was never in the equations. Meaning is something humans create after the facts are in. Physics gives you the fact. What you do with them is your business. The simplest quantum idea, revisited. Let's return to the beginning. The simplest quantum idea was this. The universe does not decide outcomes in advance. Now you see the full weight of that statement. It means no hidden answers, no secret causes, no predetermined stories. Only probabilities and outcomes when required. Why everything still works. Despite all this uncertainty, atoms are stable, chemistry works, life exists, technology functions. The universe doesn't fall apart just because it refuses to explain itself. That should tell you something. The more deeply we understand quantum mechanics, the less it resembles human reasoning. And yet it describes reality better than anything else we've ever invented. That's not disappointing. That's impressive. The last lesson they don't emphasize. Here it is, the lesson beneath all the others. Understanding does not require comfort. It requires honesty. Quantum mechanics is honest. And honesty, as you've noticed, can be very uncomfortable. The simplest quantum idea breaks your intuition because your intuition was never designed to survive it. Nature doesn't guess. It doesn't hesitate. It doesn't explain itself. It simply produces outcomes with perfect statistical obedience in a universe that was never written to be understood in advance.